Okay, working orange today. We are group 1 and it is Friday. Not a very good day when it comes to history, but still the 11th of September. Where's my mouse? So we'll write it just one more time to try and get it into our heads that when triangles are similar, and I'm going to use the symbol similar, corresponding angles are equal and corresponding sides are in proportion. What does that mean? That means that the fractions are equal to each other. When I talk about the ratio, I'm talking about that fraction. Each of those fractions will be equal. So before we go to our worksheet, I'm going to do an example and we're going to do it together. So while you're still writing that, I'm going to draw my example. Okay, we finished writing that? Let's look at our example. So I'm telling you that they are in proportion. So we don't have to do the work. Okay, so I'm not asking you to prove. I'm asking you to use that they are in proportion. So if those triangles are in or are similar, then those corresponding angles are equal. So therefore, corresponding angles equal, and therefore the corresponding sides are in proportion. So if the corresponding angles are equal angle A would be equal to which angle? Remember, it's not about what you see, it's about how the triangle is named. So just because they are both on top does not make them equal angles. A must be equal to D, B must be equal to, and C must be equal to F. Not how you see it. Okay, and I did that on purpose because I knew you were going to make that mistake. So then, which are my corresponding sides? AB corresponds to DE. Good, you're getting it. BC would correspond to, BC, EF, and my last one, AC and DF. Now so since they are in proportion, that means that each of these fractions is equal to each other. How can I say that? Well, I know because they are similar. Triangle ABC is similar to triangle DEF. By saying they are similar, we are saying that those ratios are equal. So what I want you to do now is substitute. Find the number for AB, DE, BC, EF, AC, and DE. Just substitute those values for me. Thirty more seconds. Okay, 30 seconds over. So you should have gotten 3 over 12, 5 over x, and y over 24. Now my question to you is, what is the true value of x and what is the true value of y? We're going to do it together, so don't worry. So I'm just going to move this up so you only see the ratios. So when it comes to solving these missing sides, we only have to deal with 2 fractions at a time. We don't deal with all 3 in one calculation. Now, if I want to solve for x, I obviously need to use the 5 over x, right? So that I can actually solve for x. Now, I need a second fraction. Which fraction am I going to use? The first one or the last one? Why not the last one? Also got another thing missing. I can only solve when one thing is missing. So perfect, I will use the first one. So now we do something called cross multiply. So I multiply the bottom with the top and the bottom with the top. So 3 times x is 3x, and 12 times 5 is equal to? How am I going to get x by itself? By what? There we go. So the true value is 20. Do you think you'll manage to do y by yourself? Do y for me and then we'll check it. So what, I'll help you start. I'll be with you now. So I'll start you with the y. I want to solve for that one. I'm going to start by using the one that does not have the missing number. Yes, you can. What did you want to do, Dylan?
I do so. I look 12 and then I look up how much is 3 times 12?
3 divided by 12?
Yeah, 4.
1 over 4, yes.
And my times divide by 4 was 20.
That's perfectly fine.
And then you must divide others.
Divide which one? This one? Well, first, you can do that first. Go for it, see what happens. So do it your way. We'll do it the same way as we did this. And then we'll prove whether or not you can use it. But yes, I'm pretty sure you can. Okay, should be done. So we're going to do it without simplifying first. So cross multiply. 3 times 24 is 72. 12y, but I don't want 12y, I just want y. The y is by itself because the 12's cancelled. 72 divided by 12 equal to 6. So what Dylan is doing, Dylan is first simplifying his fraction before he multiplies. So he's saying that, I'm going to do it here in the space in between. He's saying that 3 goes into itself once, into 12 4 times, and that is equal to y over 24. Then, are you cross multiplying or are you taking the 24 over?
You must,
So what he's done is he's, without even knowing it, he has cross multiplied. So 24 times 1 is 24, and 4 times y is 4y, and then he's dividing by 4. So those are all the steps that he's doing in his head without even realizing it. And it's getting us to the same place. So you can sometimes simplifying that fraction means a much smaller multiplication, but you will get to the same place. Okay. Let's go to our worksheet. Exercise, the last printed page, number 1. We're talking about triangle A, B, C, and E, F, D. Anyone still busy with the board? I don't see anyone putting their hands up, so let's look at that first example there. So, if triangle ABC and triangle EFD are similar, that means angles are equal and sides are in proportion. So, which angle is equal to A? Looking at the names, okay? E, sorry, Erin, I didn't see your hand. And B, F. And D, C and D. So we could have also seen it on the diagrams, right? We can see the 80 and the 80, the 60 and the 60. 2 angles are equal, So the third one is also equal. Now, but that wasn't my question. We were just going through the information. My question is, calculate the length of AB. So if it is similar, we immediately write which sides are in correspondence, and we write our fractions. So getting my paper out. So which side is going to correspond to AB? EF. And BC? And AC? DE or ED? Okay? So we know that this has to be equal. Each of those fractions must equal each other. And my reason for being able to say that is because triangle ABC is similar to triangle EFD. Remember, I can't write anything without a reason. That's my reason. They are similar, so the fractions are equal. Then we're going to substitute. Substitute in everything that you can substitute. So if you don't have a number, you'll just leave the letters behind. Okay, your substitution should look like that. AB could not be substituted, so I left it as AB. EF was 18, BC was 7. Oh, I did something wrong here. BC is 7, FD is still FD. Then it was AC is 3, not 7, sorry. AC is 3, and then DE is 9. There we go, 3 over 9. My first question on your worksheet says, calculate the length of AB. So which fractions am I going to use to try and find AB? 3 over 9, and obviously the one that's got AB in it. So do that. Equate them because they are equal. 3 over 9. You can simplify first if you want. I want you to find AB for me, please. As soon as you have an answer, put your hand up, please. I'm not asking you to answer, I just want to see who's done. And I wanted to focus more on what we're doing than passing things around, please. You're not supposed to pass things around anyway because it is contamination. Okay, should definitely be done by now. Cross multiplying. 18 times 53. Hands up, not shouting, please. I just said hands up, not shouting, please. Okay, 54. 9 times AB. Yes, Keenan? 9AB. So, do we want 9AB? What's my next step with the hands up, please? Not just Keenan or Dylan or Rio, other people also in the class. Someone else, anyone else? Alita, if I don't want 9AB, how am I going to get rid of that 9? So if I have 9 times AB, how am I going to get rid of it? Erin?
Do 9AB over 9 and then cross cancel?
So when cross cancel is when I go over an equal sign, it would just be cancelling. Okay? So your idea is correct, just the word you use means something else in maths. But we would divide both sides by 9. 54 divided by 9 is equal to? Keenan? No.
34. Oh.
Dylan?
Oh, sorry.
Equal to 6. So I'll repeat that. If I want the letters by itself, whatever is in front of it, I divide by that number. And I do it on both sides. So calculate the other missing lengths, please. FD. Calculate FD as well. Because that's my next question in your exercise. Calculate the length of FD or DF. I don't even know what they say. I know. But most of you are doing your own sums, so you only look up when you're done. Okay, solving for FD, which means I'm taking the fraction that's got FD in it and the one that's got all the numbers. Going to cross multiply, so I'm going to get 3FD. 9 times 7 is 63. I want to get rid of the 3, so I put it over 3 so that they can cancel, but it means that this side must also be over 3, and 63 divided by 3 gives me 21. Yes, Anita. That's fine. Okay, you can definitely remember both sides are equal, so it doesn't matter which side I write first. Okay? Any questions? Yes, Lorna. The 3 from the fraction. Yeah, I took those two. Then FD times 3 is 3FD. Here.
No, no, no. 63 over 3.
Why is it 3?
No, yeah, 3 also.
Because I have 3 in front of the FD. Can you see that? Now I want FD just the letters, no numbers. So whatever's in front of it, I divide by exactly the same thing. So if that was a 5, this would be a 5. If that was negative 3, that would be negative 3. If that was positive 650, that would be positive 650. Whatever is next to the letter is what I put in the bottom. And when I put in the bottom this side, I must also do exactly the same thing on the other side. Okay. Is that clearer for those who were a little bit confused about that? Okay. Let's look at my next example. And now they are asking me to prove before I calculate. So my first question you should be able to do, prove that triangle TUV, they give you the name, is similar to triangle TWX. So the T's are corresponding, the U and W is corresponding, and the VX is corresponding. So quickly prove that for me, please. Prove that they are similar. In proper format, please. So in triangle TUV and triangle TWX, yes, Aaron, sorry. Yes, you may. Okay, let's see what our similarity proof looks like. So I start as we've been taught in the two triangles that I'm dealing with, and they gave it to me in the question, TUV, TWX. So in triangle TUV and TWX, T is common. Or you could have said UTV equals WTX, and your reason is common, but it is common. Okay, so they are the same size. Then I have parallel lines, so I'm going to use my F, that angle, and that angle is equal. So TUV is equal to TWX. Okay, and my reason is corresponding angles are equal. UV is parallel to WX. Then I can use third angle of triangle, or I can use the other corresponding on this side. TVU is equal to TXW. And I use corresponding again. Corresponding angles are equal. UV is parallel to XW. I just accidentally mixed those letters up. It wasn't on purpose. Okay? Therefore, triangle TUV is similar to TWX, angle, angle, angle. If you don't do that, you are technically not allowed to do what comes next. Because you must show that they are similar before we do the ratios. So if they are similar, that means that the corresponding sides are equal. So they are in proportion. TU and TW are my corresponding sides. UV, WX, and TV, TX. So I just wrote that immediately. And I wrote that because that they are similar. So I wrote that because they were similar. And now I'm just going to substitute in the values. Okay? I'm going to substitute, the values that I can see on those diagrams. So TU is 6, TW is 10. UV and WX, I just left as that because I had no numbers. And TV was 2, and TX also does not have a number. They asked me to calculate TX, so please calculate TX if you haven't already. Only giving you 1 minute, and yes, you will land up with a weird number. Does anyone know not know why I said 10 and not 4? Look at your diagram again. So remember, you see we got 6 and we got 4, right? But does it ask you for UW? Is my corresponding UW and TU? No, it is TU and TW. So I need to take the whole side, which is 6 plus 4 is what gives me my 10. So look very careful at which letters are corresponding. Okay, let's have a look. So 6, I'm going to use the 6 over 10 and the 2 over tx, telling me I need to cross multiply. So tx times 6 is 60x and 10 times 2 is 20. Now I want tx by itself, so what am I going to divide by, Lorna? By 6, because that's the number in front of the letters. So dividing both sides by 6, which I forgot to write. 6 is cancelled, leaving me tx, but then I'm going to get this weird 20 over 6. And I just simplified it according to my calculator, 3 1/3. So that is the value of tx. So the whole side of that triangle. So from t to x, the whole side is 3 1/3. My next question asks me for vx. What is the value of vx? Dylan? 1 1/3. The whole length is 3 1/3, which means that portion plus that portion makes up 3 1/3. So if we know that one portion is 2, plus what gives me 3 1/3? 2 plus what gives me 3 1/3? 1 1/3. Or we could write it this way, using our equations. TV plus Vx. TV plus Vx gives me 3 1/3. Sorry, thank you. We know that TV is 2. We still need to solve for Vx. We have plus on this side. When we take it over, it becomes minus. So 3 1/3 minus 2 gives me my 1 1/3 that I needed. Okay, I want you to carry on with that worksheet. In 5 minutes time, we will look at number 3, and then 4 and 5 you are going to take home and do. And as soon as Miss Saunders has that memo, you're going to mark, okay? So we have given you all the different triangles that you could expect to get. Obviously the values might change, but the shape of those triangles will be the same. So start with number 3. First prove that they are similar, and then calculate the missing values. Keenan, number 3.